Alright guys, today's goal, the learner will understand how to graph polar equations. Okay? Polar curves and parametric curves, symmetry, analyzing polar curves, Rove's curves, Lyman curves, and other polar curves. And why? Graphs that have circular or cylindrical symmetry often have simple polar equations, which is very useful in calculus. Okay, so let's take a look at some facts first. There are 3 types of symmetry figures that can be considered. Okay? The x-axis, polar axis, as a line of symmetry. Okay, so for the x-axis, if you have r theta and r negative theta, then that would be equal to negative r times pi minus theta. And it's just reflected. So if you look, if you say you have radius of 1 and 45 degrees, here if you have 1 and negative 45 degrees. Okay? The y-axis, the line theta equals pi over 2 as the line of symmetry. So if we look at here, if we look at r being 1 and theta being pi over 2, or sorry, pi over 4. Now if we look over here, if we say 1 comma pi minus pi over 4, that would be negative 1. They're telling us that would be negative 1, 3 pi over 4, which is what that angle is. Okay, that's what they're telling you. Okay, so here if we say 145 degrees, this is for it's about the origin. Okay, 1 comma 45 degrees. Here it says negative 1 comma the 45 degrees, or really you're moving at an absolute value of 1, and you have 5 pi over 4, or sorry, we're in degrees here, 225 degrees, because technically r is always going to be a positive value because it is the magnitude. So, alright, so let's look at the next steps here. Symmetry tests for polar graphs. Okay. To test if something about the x-axis, replace r comma theta with r negative theta, or negative r pi minus theta. About the y-axis, r theta with negative r negative theta, or r pi. And about the origin, r theta, negative r theta, or r pi plus theta. So whichever one looks easier to do for the problem. So let's take a look at an example of what we have to do here. It says use the symmetry test to prove r equals 2 sine 2 theta is symmetric about the y-axis. Okay? So if I look back for symmetry about the y-axis, see how it says negative r negative theta? Let's use that. So if I plug that in, I get negative r equals 2 sine 2 negative theta. Well, that equals negative r 2 sine negative 2 theta. And remember, we learned sine of negative theta equals negative sine theta. That was last try. So then I have negative r equals negative 2 sine 2 theta. Divide by the negative 1, you get r equals 2 sine 2 theta. See how we ended up back with the same thing? Therefore, it is symmetrical because we proved it. Okay? Alright, let's start looking at some of the curves now. Okay, it says the graphs of RA cosine n theta and RA sine n theta, where n is an integer greater than 1, are Rose curves. If n is odd, there are n petals. If n is even, there are 2 n petals. When n is odd, the entire curve generated as theta increases from 0 to pi. The curve has n petals. We talked about that. When n is even, the entire curve generated as theta increases from 0 to 2 pi and has 2 n petals. Okay, so here n is odd, so it has n petals, so we know it has 3 petals. This is what this graph looks like. See how it has 1, 2, 3 petals? And it looks like, so if we take a look, there's 1, 2, 3 R's. But to go from 0 to 2 pi, it's going to go through this twice. Okay, and we'll play with this in class. Remind me. Okay, so let's go back and look at when we learned how to graph these. Okay, so we know A is 4, B is 3, period is 2 pi divided by 3, and the scale is pi over 6, because remember you do the period times, or divided by 4, so you get pi over 6. So let's take a look at this graph real quick. Okay, so take a minute and press pause and copy down this graph. Now, I'm only doing half of the 0 to 2 pi, but we'll look at this. So, alright, remember, cosine starts at its maximum. And then when you move pi over 6, it goes to the 0, to the min, to the 0, back to the max. Okay? And then you'd go to the 0, back to the min. Okay, so let's actually go all the way to 2 pi. Okay? So that would be 3 pi over 2, 2 pi. And then if we keep the graph going here, 0, max, 0, min, 0, max. Now, it looks like that there's only 1, 2, 3, because you don't include the last one, okay? But it looks like there's only 1, 2, 3 maximums, just like it did here. But this goes around, like I said, this is going to go around this loop twice from 0 to 2 pi, okay? Now, the reason is, remember, R is considered the magnitude, so all of these negative values would shoot up. So you get R equals, or you have, so we know we have 6 maximums. So now we have to find it polar coordinates, okay? Okay, so we have to think on this graph what these 3 points are, but also based on the angles. So, what we're talking about here is, where do we start on this graph? 4, 0. And then we go down to here, isn't that negative 4, pi over 3? And then if we went up to here, it would be 4, 2 pi over 3, and then you'd have negative 4, pi, because we're down here now, and we go up to here, and that would be 4 comma 4 pi over 3. And then we go back down to here, and you get negative 4 comma 5 pi over 3. But r is going to be 4. Even though this says negative 4, negative 4, negative 4 for those three of them, that's actually a maximum value of 4, because it is considered the absolute value of it to be able to get the length. Okay? Alright, so one more. Now, here it says the Lymakin curves are graphs of polar equations of the form r equals a plus or minus b sine theta and r equals a plus or minus b cosine theta, where a is greater than 0 and b is greater than 0. There's a lot of rules here. So it says inner loop, 1, a dimpled, and a convex. Okay? So let's take a look. Analyze the graph of the polar curve. So if I look at this, I know that it is, since 1 divided by 2 is less than 1, I know it's going to have an inner loop. Now we also need to tell it the maximum. So if we think about the graph this way, since that k is 1, if I were to make a graph, it means I'd move the 0 up 1, and then a being 2, that means up 2. So what's our max? 3. So our max is equal to 3. What's the domain of this function? All real numbers. What's the range? Well, look at this graph. So if there's the 0, it's at 1. If I go down 2, I'm at negative 1. So the range is negative 1 to 3. Okay. It's continuous because there's no break in it, so we say continuous. Is there any symmetry? Well, if we were to look at this graph, it would look essentially like that. So yeah, it's symmetric about the y-axis, and we could prove that. Is it bounded? Yes, because it's wrapped up like a little circle almost. We already talked about the maximum. Are there any asymptotes? No. Okay, these are things you need to talk about every time it asks you to analyze. Alright guys, see you tomorrow.